you very much. So this is one. This is one for omega equals 0. This is 1. This is alpha. So it is going to be 2 over 1 minus alpha. So I would like to make my gain at z equals or omega equals 0 because this is a low pass filter arkadaşlar. Low pass filter. So this value is the highest, right? If I'm dealing with low pass filter, omega equals 0 will give me the H max value. Okay? Maximum value will be obtained for DC, for omega equals 0. Okay? That's why I do this. I put omega equals 0 and I find this K. Why do I have this K arkadaşlar? K is a kind of coefficient in order to make this unity gain filter. Anlıyor muyuz burayı? I want to make this unity gain filter because if K is 1 minus alpha divided by 2, for the maximum value of this, it will be equal to, multiply this by this, it will be equal to 1, right? This will be cancelled out, this will be cancelled out, and I will have 1. So, for omega equals 0, if I have this as K times this will give me 1. That's why I'm writing K as 1 minus alpha divided by 2. Anladık mı burayı arkadaşlar acaba? Yes? So, K is 1 minus alpha divided by 2. Alpha, what is alpha? My pole. My pole here is alpha. Bakın şurası. My pole is alpha. What is my 0? It is 0 here. Okay? If I change my alpha like this, my pole 0 diagram will change, right? Değil mi arkadaşlar? 0 will stay, but my pole, according to my alpha value, my pole's location will change. What is the effect of this pole, changing the pole? What is the effect? It will change my frequency response. It will be a totally different filter arkadaşlar. I am trying to design such a filter for my own specifications by changing alpha. This is a first order IIR filter. First order low pass IIR filter. Neden first order? Because z to the power minus 1. If I have z to the power minus 2, then I will say it is a second order low pass filter. Anlıyor muyuz arkadaşlar? So,
Hocam, can you say again?
The power of z will give me the order of the filter. Just like the order of the polynomial. You remember the polynomial order? X3, third order polynomial. X to the power 4, fourth order polynomial. Now, I have polynomials with z to the power minus 1, minus 2, minus 3, minus 4. If I have a z, which is z to the power minus 4, then my low pass filter or high pass filter or anything like that will be second order, third order, fourth order. Anlıyor muyuz arkadaşlar?
Hocam, it could be in the numerator or the denominator, it doesn't matter.
It's usually in the denominator, Anya. So here, if we see it here, then it will be a second order. Let me show you one thing. For example, arkadaşlar, this is a second order band pass filter. You see, this is z to the power minus 1, z to the power minus 2, minus 2. Okay? So, this order will affect my filter, okay? The number of poles and zeros. So, for example, here, when I see this pole zero diagram. How many poles do I have? One.
One.
How many zeros do I have?
One.
One. So the number of poles will give me the order arkadaşlar. The number of poles will give me the order of the filter. The number of poles will give me the order of the filter. Okay? Şimdi burası biraz anlaması zor ama buraya dikkatinizi çekmek istiyorum. Ben de bunu seneler sonra anladım.
Hocam,
Şimdi I have this. Yes, Anye?
just finish our
Okay. So this is my unit circle arkadaşlar. I have my zero here. Let's say I have my pole here, okay? How do I draw this stuff? And how do I see the change of alpha will change my frequency response? How do I do that? Here is the trick. I have a vector like this. This point is my vector. What does it mean? It has one magnitude. Omega is zero. So it's a vector like this. Okay? Anlıyor muyuz burayı? Vector with no angle, zero angle. With x-axis it is parallel. Okay? Arkadaşlar, I will change my omega like this and try to find out this characteristic. Okay? And understand what I'm doing? I'm going to change the frequency. I'm going to change the frequency, which means these frequencies, I'm going to find out for different frequencies, I'm going to find out the magnitude. Okay, what do I mean by magnitude? Magnitude of this. This, amma karışık oldu. This divided by this, okay? 1 plus k times 1 plus z to the power minus 1 divided by 1 minus alpha z to the power minus 1. I am trying to find out this ratio as my magnitude response for different omega values. I'm going to change omega and find out this ratio, which will give me the frequency response in omega. Okay? Anlaşıldı mı arkadaşlar burası? Let me explain this to you. Bakın şimdi, if omega is zero, what is the distance between this and this? This is alpha. What is the difference between this point and pole? 1 minus alpha, right? Because my z is 0. Z to the power 0 is 1. This is my distance. Bakın, when my angle is 0, the tip point is 1. And here is my alpha value. Understand? This is my tip value for my value, but this is my pole. What is the difference? This is alpha, this is 1. Okay? So the difference is 1 minus alpha. What is the difference between this point and my 0? 2, right? What is the difference between this point and this point? Let's say this is my 0, this is 1. What is the difference between this point and this point in terms of distance? 2, right? 2. So now, can I immediately put it here? 1 plus 1 divided by 1 minus alpha times k. What is my magnitude here for omega equals 0? Magnitude means 1 plus e to the power minus j0 divided by 1 minus alpha e to the power minus j0 times k. What is the value here?
Two over 1 minus alpha.
2 over 1 minus alpha times 1 minus alpha over 2, right? This is my k.
Yes.
So what's the output?
1.
1. The ratio between the, bakın, the distance from this point to my 0 will be my numerator. distance from my point, which is like this, alpha omega is 0, and my distance is amplitude is 1. Numerator is found by this distance. Divided by denominator. What is the difference? This point and my alpha value, and my pole value actually. So it is my denominator, okay? Times k. I will do this for all omegas. For example, if my omega is this, let's say pi over 4. What is the difference between this and this? How do you find the difference between this point and this alpha value, or this pole value here? How do you find that?
Square root of 2.
It will be a little bit complicated, right?
Cosine.
Because it is like this. Yani biraz daha geniş çizecek olursam. I am trying to find out the distance between this point and my pole. This is the origin. This is 1. This is my point, e to the power j omega. Okay? So this is my point where my z is, okay? So what is this distance? How do you find it? This is cosine omega. This is sine omega. This part is sine omega, right?
Yeah.
This is 90 degrees. This is also 90 degrees. Right?
Good.
Hocam cosine teorem maybe.
Cosine theorem, right. So I know this is alpha. I know this is 1. How do I find this? What was cosine theorem? Square of 1 plus square of alpha minus 2 alpha times cosine omega.
Yes.
Okay? So arkadaşlar, I am thinking always in terms of distances between my angle of omega and to my pole and to my 0. That gives me this characteristic. How do I plot this? For each omega, I find the difference between this point in z plane and my pole and 0. The ratio between the numerator and denominator times k will give me the h value, the gain value for each frequency. You know, anlıyor muyuz burayı arkadaşlar? Because I have to find out what is the gain for each frequency value. That will give me the information about how my filter will behave for each different frequency input. Okay? I will have an input to my filter at a certain frequency, and I will see what the output will be. It will still be in omega, but the magnitude will be changing from A to A times, let's say 0.8. Okay, because it's a filter. What happens arkadaşlar if my alpha value increases? What happens if my alpha value increases, becomes close to 1?
The gain increases.
I think the transition band becomes steeper.
Mustafa, I couldn't hear you.
The transition band becomes steeper.
It will be like this. Why is that so?
The numerator value would increase, so the gain increases.
So this one will go from here to here, right? It will be close to 1. So what is the difference between this point and this point? Like this was like this, now it is like that. Şöyle bir
The distance also increases.
So what was my ratio here arkadaşlar? Yani emin değilim bu kadar detaya girmekten ama bunu da anlatmazsam bunun anlaşılmasının zor olduğunu düşünüyorum. Bakalım bir deneyelim. Okay, this is omega. This is the distance. For example, this is another omega. Again, if I change my distance from here to here, I'm increasing alpha. Alpha is going towards 1. And this is my omega. What is the difference becoming like? The difference between this and my 0 will not change, right? Alpha doesn't affect the difference between my point here and my 0. So this will not change with alpha. Only the denominator will change with respect to alpha. So what is changing as I go further?
Distance become larger.
The distance becomes larger. How about if I have such an omega value? What is the difference between this or like this one?
Almost 2.
Like they will be, bakın, they will be very similar to each other, right? Distance between this and this, and distance between this and this will be almost close to each other when I increase omega. But for smaller omega, bakın bu sefer small bir omega koyuyorum. Okay. Şöyle yapalım. Smaller omega'da durum şöyle. The distance between this one and this one will be much higher. That's why the distance, the differences are more visible for smaller frequencies, for changing alpha. Yani, this is my message. How do we plot these figures? Frequency response figures. It is actually a vector and a point in space in z-plane. The difference between this point and 0 divided by this point and pole will give me my h value. Okay? When I increase omega, bakın omega is increasing, the distance between this point and 0 is going to be lower, and this point and pole will be higher. What does this mean? Omega is increasing, h is decreasing. This is low pass filter. Anladık mı burayı arkadaşlar? If I, bakın, I am increasing my angle, my radian, my frequency, angular frequency. The distance between this and this will increase as I go further. Okay? But the distance between this point and 0 will become 0. So this will go if as I increase omega, numerator will decrease, but the denominator value will increase. So it will be a low pass filter. That's the message here. I think you need to work on it on your own, plot something and see how the distance is changing. But that's the main idea here, okay? So this is a low pass filter. Let me tell you the advantage of IIR filters is that with lower orders, you may obtain better filters. Okay, better means sharper. Okay, with low order. For example, if you want to have an FIR filter, you need to go up to 10 order, for example, 10th order. But with IIR, it is possible to have it with, let's say, 3rd order. Okay, with even less number of components will be enough for you, and less amount of delay will come after the IIR filters. Okay.
Hocam,
Yes.
from this transfer function, can we easily identify that this is an IIR filter?
Yes. If you have a numerator and denominator, this is an IIR filter. That's the only thing. If you have the numerator and denominator both sides by Z, if you have Z upper side, Z below side, numerator and denominator, that's an IIR filter.
Okay. Yeah.
Let me write an FIR filter H of Z. This is an FIR filter H of Z. Okay, there is no denominator here, only numerator. Denominator is 1.
Okay.
Anlıyoruz değil mi arkadaşlar? Bu
Evet.
detayı, bu fark anlaşıldı mı acaba? Okay. So, arkadaşlar, this alpha value, as I said, I won't go too much detail again. This alpha value will be the key point in your designs. Şimdi hatırlayın, we always did something like that. Like, can you find H of n of this impulse response? Immediately, can you tell me what the H of n? Please write to chat. What is the H of n of this filter? Nurefshan, did you say something?
No hocam.
Arkadaşlar, elde kalem. I want you to write H of n. First on your papers, then to the chat. Reminding. Arkadaşlar, if you remember, I was writing H e to the j omega as magnitude times the phase, right? J and let's say delta omega, okay? Theta omega. This is called magnitude response. This is the phase response, okay? This is the phase part. What is zero phase filter? Zero phase filter means there is no phase. Theta omega is 0, okay? For example, if H e to the j omega is always 0.9, there is no phase here, right? There is only real part. There is no imaginary part here.
Yeah.
Any questions?
No.
So it will be a zero phase, but it is not usually possible to have zero phase filters. That's why we design constant delay filters. That means linear phase filters. Constant delay means my omega, my phase value will change always with the same kind of delay amount. For all omega values, I will have, let's say, my frequency, my signal like this, okay, with changing frequencies. My output will be delayed. Bakın bu, this was 0 second. My output will be delayed by 0.1 second, and it will be this similar stuff, okay, with some filtering. There will be a delay between the input and the output. All filters will impose a kind of delay in your input. Anlıyor muyuz arkadaşlar? You have a filter. You're sending a signal. Maybe you see this in EEG signals. Please check this on your EEG signals. You're using an input signal, EEG, and you're using Butterworth filter. There will be a delay in your output. You will not obtain the output immediately as you give the input. There will be a delay in your output. Okay? Anlıyor muyuz arkadaşlar burayı? So if I'm sending this pulse as my input, I'm going to obtain a pulse like that. Yani düzgün çizemedim ama şöyle. I will obtain always a pulse with a delay. Okay? There will be a delay in my filters. Okay? What is linear phase filters are, what linear phase filters are doing is that I will have a fixed amount of delay for all frequencies. Let me tell you again. I will have a fixed amount of delay, constant amount of delay in my filter for all frequencies. So it doesn't give me for this kind of frequency, it has this kind of a delay. For another frequency, there is another kind of delay. No. Okay, I will have all fixed amount of delay for all frequencies. Okay, this is called linear phase. This is called linear phase filters. Okay, so how do I come up with such a linear phase filter? Here is the trick. I have my magnitude response, but I will rewrite it as e to the power minus j d omega times some value. Do you remember what we have done before? We said e to the power j omega over 2 times cosine omega over 2. Do you remember this? Do you remember this last time, yesterday we wrote that? Arkadaşlar hatırlıyor muyuz burayı? Ne yapmıştık? Dirac n plus 1 over 2 Dirac n plus 1 over 2 Dirac n minus 1 was, in terms of Fourier transform, we found that it was 1 over 2 e to the power j omega, pardon, 0 plus e to the power minus j omega. Right? Then we said, okay, it is like e to the power minus j omega over 2 times cosine omega over 2. Do you remember this, arkadaşlar? We have done it twice.
Yeah.
In one case, it was cosine. In the high pass case, it was sine. Do you remember that? Yes?
Yes.
So this is a linear phase filter. Why? Because I have my magnitude response and I have a fixed amount of delay for all omegas. What is my amount of delay? Bakın neydi? Minus j omega over 2. What is my d here? What is my d here?
Minus 1 over 2.
Bakın, minus is here, Anya. Minus is already here. I'm after this d. What is this d?
1 over 2.
1 over 2. If I have such a constant value between minus j and omega, then this is a linear phase filter. Anlıyor muyuz burayı arkadaşlar? Next to it, I will have cosine omega times sine omega, something like that. But I will have an e to the power something. E to the power minus j. How do I design such filters? Using symmetric and anti-symmetric filters. What do I mean by symmetric filters? Here is a symmetric filter. Symmetric around a symmetry axis, around this. For example, this is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and my values are like this. Around an axis, both sides is symmetric. Why is this linear phase? Bir örnek vereyim, anlayacaksınız gençler. Çok basit. Bakın, here is a linear phase filter. Zero, 1, 2, 1, 2, 1. Let me write h of n. Dirac n plus 2 Dirac n minus 1 plus Dirac n minus 2. Yazabiliriz değil mi buradan buraya? Can you move? What is h e to the j omega? 1 plus 2 e to the power minus j omega plus e to the power minus j 2 omega. Değil mi? What is the middle point? What is the middle point here? This one is my middle point. Bakın yazacağım şimdi. Bakın. E to the power minus j omega is my middle point. Times e to the power j omega. If I multiply these two, I will get 1. E to the power 0. Takip ediyor muyuz gençler? Okay miyiz? What is my number here? E to the power
Complicated.
0. Right?
Oh, yes.
Doğru mu?
Tamam.
Tamam. It should be 1, right?
1.
Sorry, 2. 2 times e to the power j omega. Here is what I have. Plus e to the power minus j omega. Bir daha yazıyorum açık bir şekilde. E to the power minus j omega times 1 e to the power j omega plus 2 plus e to the power minus j omega. What is this part? 2 plus cosine
Sine.
omega times 2. Neden? E to the power j omega plus e to the power minus j omega divided by 2 is cosine. What is this addition of these two? 2 cosine değil mi? This by this add by this, divide by 2 is cosine. So this by plus this is going to be 2 cosine. I already have this one in my hand. So finally, I will have a magnitude response times my phase response. What is my phase here? Minus omega. What is my delay here? What is my d?
1.
1. 1 delay means 1 sample delay. 1 sample delay. So if I'm giving an input, the output will be 1 sampling period after the input is entering my filter. If d is 1, the output will appear at the first sample will appear at the output after 1 sampling period after 1 sampling period or 1 sampling period after the first sample, the first input sample enters my system. Yani bu girdi, this entered, this will appear at the output 1 sample later. For example, if my sampling period is 1 second, it will appear 1 second later. If my sampling period is 0.1 second, the output will appear at 0.1 second later. it will be a delay. Okay?
Hocam, how we deduct the delay is just 1? Is it because of e to the power minus j omega?
Exactly. Here, as I explained you here, bakın, we take theta omega is equal to minus d omega. This d value will give me the delay amount.
Hocam, it should be middle point, right? In the our h of n function.
Exactly. That's neredeyiz? Şuradayız. It will be it will be the middle point arkadaşlar. Yani if it is a symmetric function like that, symmetric impulse response like that, the middle point will be your delay amount. If it is something like this, 0, 1, 2, 3, 4. What is the delay amount?
2.
2. Middle point will give me the delay amount. If my length is even, there is no middle point arkadaşlar. Bakın. 1, 2, 3, 4, 5, 6, 7, 8. Şöyle yapalım. Buralarda 0 olsun. Şu da 0. So what is my middle point? 4.5.
4.5.
4.5 times sampling period will be my delay amount in seconds. Yani tomorrow in the quiz I will tell you design a linear phase filter. I want you to know what is linear phase filter and how I can design it and how I can have the impulse response, how I can find the frequency response and the delay amount related to this design that you have. Okay?
So how can we design a linear phase filter? No light.
Elektrikler kesildi. Yanlışlıkla benim ofisimin elektriğini mi kapattılar? Ne yaptılar? Arkadaşlar ben buradayım. Ben dersteyim. Elektrikleri kestiniz galiba. Efendim? Bilmiyorum, burada bir sıkıntı oldu. Benim dersim var ama. Arkadaşlar ben karanlıktayım ama her şey devam ediyor. Şalter olsa internetim çalışmaz. Neyse böyle devam edeceğim artık. Başka çaresi yok. Telefonumla bir şekilde şey yaparım. Işık yaparım kendim. Nasıl? İyi olur. Çok memnun olurum. En azından araları şey yaparsak. Çok az kaldı zaten. So Anya asked me that how I will design a linear phase filter. This is a linear phase filter. This is a linear phase filter. This is a linear phase filter. This is a linear phase filter. This is a linear phase filter.
These are the impulse response of the field.
This is the impulse response of a linear phase filter, right?
Okay.
This is a impulse response of a linear phase filter. Bu kadar basit arkadaşlar. Either it is symmetric or anti-symmetric. What do I mean by anti-symmetric? Hop. Bakın, around the origin it will be negative, right? Negative of this, negative of this. Anlıyor muyuz acaba? 1 minus 1, 2
Hocam,
minus 2. El hareketi yapıyorum ama beni göremiyorsunuz ihtimalle. Evet, pardon, dinliyorum.
Hocam, isn't it high pass filter for the like minus sign? If there's a minus sign, it should be like high pass.
Very nice, very nice. This will be, if it is symmetric, it will be something like that, which is a low pass filter. And if it is negative like this, then it will be a high pass filter. An anti-symmetric filter will give you a high pass filter. We have done these two things. They are already linear phase filters. Okay? And I want you to come up with, let's say, if I have this, what is my HE to the j omega? Okay? 0, 1, 2, 3, 4. At home, I want you to find out what the h of n is, what HE to the j omega is, and then how you will find the delay amount for this filter. You understand what I mean, arkadaşlar? So what does linear phase filter mean? Arkadaşlar,
Has a certain delay.
there is always this constant phase delay, constant delay for all frequencies. Bir de bakın isterseniz, yani if you don't have a filter, a symmetric filter like this, okay, come up with such a filter, and in MATLAB, draw the phase response of this filter using freg_z MATLAB command, freg_z. Come up with a symmetric filter, an anti-symmetric filter, and then see the magnitude response and phase response, and also come up with a filter whose impulse response is neither symmetric nor anti-symmetric. Anlıyor muyuz arkadaşlar? freg_z. freg_z helps you to plot the magnitude and phase response of a filter.
So, if it's neither symmetric nor anti-symmetric, it's not linear phase.
It is not linear phase, Anya. Exactly. It is neither zero phase nor linear phase. Neither nor'u da 2 defa cümle içinde kullandım gördüğünüz gibi. Cem Yılmaz dalga geçiyordu ya, neither nor falan, neither nor'lar, shall'lar, shant'lar falan diye. Evet. Peki. So linear phase, is this an FIR filter or IR filter?
It's already written hocam FIR.
Evet, cevap tahtada yazıyordu. Sizi trikledim. FIR filter, because I can these are FIR filters. You know, H of n is this, right? Dirac n plus Dirac n minus 1. Is there a y component here? If I write the H of n of this one, Dirac n plus 2 Dirac n minus 1 plus 3 Dirac n minus this and that. This is an FIR filter, right?
Yes, FIR, yeah.
Y of n is equal to x of n plus 2 x of n minus 1 and so on.
Hocam, how do you know? At least we need the frequency response to know, right? The transfer function.
Say it again, I couldn't understand.
We need the transfer function to know if it's an FIR or IR.
Exactly. Either if the h of n is given to you, bakın arkadaşlar, if h of n is given to you, then like this, you're going to write h of n and see if this is FIR or IR, or h of z or HE to the j omega will be given to you, and you're going to understand that it's an FIR or IR filter. Okay? Usually, arkadaşlar, IIR filters, you will not be able to see h of n like that. Okay? If you see h of n like this, it is an FIR filter.
Hocam, how was like IIR filters graph?
What's that?
Hocam, how was like IIR filters graph?
For h of n, arkadaşlar, for example, how did we find h of n before? If you remember this, ne yapmıştık? Hatırlayın burada.
It's Diracs.
There were many Diracs, right?
Yeah.
You remember how was my How was my h of n? Where is it? This was h of n. It will be infinitely long. Değil mi? If you drove the h of n of this, it will be like this, like this, like this. It will go to infinity. So IIR filters are infinitely long, have infinitely long impulse responses. FIR filters have limited number of samples, limited number of components in them. Anlıyor muyuz arkadaşlar burayı? What is FIR? Finite impulse response. Finite impulse response. Like this one, finite. Like this one, finite. If it is infinite impulse response, it goes to infinity.
Hocam, does it go to infinity?
This one?
Yeah.
Exactly.
There
What
is
did you
feedback.
want?
Okay. But
That goes from 0 to infinity, right?
it does it. Oh, un minus 1. What about un minus?
Un minus 1 will start from 1 and go up to infinity, right? Again,
Okay.
both are infinity. They are going to infinity.
I get it. Yeah, of course.
Arkadaşlar, I want you to realize the difference between IIR and FIR. I want you to be able to write a difference equation from an impulse response or transfer function. I want you to be able to come up with a, let's say, linear phase filter and show that it's a linear phase filter. Okay? And tomorrow, inshallah, like around 40 minutes, I will explain some more filtering based stuff. And if you have any questions for the quiz tomorrow, we will have a session tomorrow at 1 o'clock. Okay, 1:10. Oldu mu
Hocam.
arkadaşlar?
For the FIR filters, there are some samples. Can we move on the FIR graphs, hocam?
This one?
Yeah, it can be.
This is an
Hocam,
FIR filter.
yeah, when we increase those samples, what is changing in the filter exactly? For example, 4 impulse we have, or 6 impulse. What is like a changing?
For example, if I have this, Emre, if I add one more,
Right.
like this, it will be a longer impulse response, and here I will have what will be my impulse
More delay.
response? There will be there will be more delay. Okay, it was half a sample, now it is 1 sample. Now it is an anti-symmetric linear phase filter, and there will still be a sign plus something value. Okay, I can show you that if you want. 1 over
Yeah,
2
no, hocam.
plus or minus 1 over 2 Dirac n minus 1 plus 1 over 2 Dirac n minus 2. Okay, 1 over 2 in parentheses. Then I will write e to the power minus j omega 1 minus e to the power j omega minus 1 plus e to the power minus j omega. This part is what? Cosine, right? Yanlış söylemiyorum. Cosine omega minus 1 divided by 2. Pardon, bu 2 buraya geldi. Bu 2 gitti. Cosine omega minus 1 over 2 times e to the power minus j omega. Ne oldu? Still, bakın bu sefer my filter became like cosine omega minus 1. Yani bu akşam ders çalışırken I want you to do this, okay? Change this and see how you are doing it. Okay? Change the h of n. How is it affecting my impulse response, frequency response?
The delay changed, right?
The delay change, your filter characteristic will change.
Hocam, when we increase the delay, will it also affect the sharpness of the filter?
No, No, it is just about the phase response. It is not about the sharpness. In order to increase the sharpness, arkadaşlar, you have to increase the order of your filter. Okay? So it was like this. You have to have an order increase for such a for increased sharpness. Okay? Anlıyoruz değil mi? This is sharper. Now it is sharper.
Mhm.
Okay?
Yes.
So this sharpness will increase as we increase the order of our filter. Sometimes even the, let's say, Chebyshev filter or Butterworth filter, those, tomorrow let me talk about Chebyshev, Butterworth and elliptic filter. What are those? At least in 1 hour I would like to talk about them. Maybe it's not going to be necessary for you in the quiz, but it may be necessary for you in the project and for the coming classes that you might have. Okay? Arkadaşlar, görüşmek üzere. Kendimi de şöyle elimi falan görüyorsunuz. Evet, görüyorsunuz. Bu da bize hatıra oldu böylelikle. Karanlıkta da ders yapıyoruz. AGÜ'de karanlıkta bile ders yapılıyor arkadaşlar. In AGÜ, at AGÜ, we do classes even in dark. So there is no mazeret. There is no mazeret. What is mazeret?
Excuse.
There is no excuse. Yani aslan gibi öğrencilerimiz var. Aslan gibi hocalarımız var. Maşallah, maşallah, maşallah. See you tomorrow at 1 o'clock, at 1:10. İyi akşamlar arkadaşlar. Görüşmek üzere.
İyi akşamlar.